in this class we are going to discuss about the next concept, that is shift register. Okay, so what is meant by shift register means already we know register is nothing but it is a group of flip-flops, right? And shift is nothing but we can shift the information here. Okay, so shift register means so each and every register we can shift the information from one end to the another end. So that is called as the shift register. Okay. So this shift register concept is a very important concept. So in order to analyze the functionality of the registers. Okay. So let us suppose there is a value in a register. Okay. So I can take one example here how to shift the information. So here I am taking one register that is related to the 4-bit register. I can take it. Okay. So the value I can consider as, for example, 0110. Okay. So now I can place it as here 0, 1, 1, 0. So now we need to shift that information. So how to shift that information means, first of all, I want to shift the data is like this, from left to right. Okay. So there is a new input I can consider, that is 1. Okay. So there is a new input 1 I can consider. Now I want to shift this 1 to the particular position. Okay, so now I want to shift this 1 into the particular position. So what will happen? This 1 will be shifted to here, and what about 0? 0 will be shifted to here, and this 1 will be shifted to here, and this 1 will be shifted to here. And what about this 0 means? This 0 will be discarded. So like this we can shift the information. Okay, so this is the how the shift register will work. Okay, so any input can be generated from the any side. So any input can be generated, that may be any side, that is nothing but either left side or maybe right side also. Okay, it could be generated from the left side or it could be generated from the right side also. So we are also that the input came from the either 0 or 1 only, because we can shift the only binary information. Okay. So like this we can shift the information. So here whatever the input we are chosen, that input either 0 or maybe 1. So we can place it as that information either left side or maybe right side also. So if you are taking here, the input will be taken as at left side, no? Serial input, that may be 1. So 1 will be shifted from left side to right side. But if you are taking right side, okay, now I can take it as 0 at right side position. So then this 0 will be placed here, and this 0 will be placed here, and this 1 will be placed here, and this 1 will be moved here. So that is nothing but totally the right side bit information will be shifted to the left side. So that means any input can be generated from the any side of the shift register. Okay, so let us understand the shift register in more detailed manner. So what are the shift register? As I am saying, register is capable of shifting its binary information in one or more directions. Okay, so this is the logical configuration of the shift register. Okay, see here whatever the diagram we are having here, this is the logical configuration of the shift register. Okay, so this shift register consists of the 4 D flip-flops. Okay, so this is the first flip-flop, second and third and the fourth one. So this is the D is nothing but input, and this is the output of first one. So this is the output for each and every flip-flop. So now I can give the numbers here. So 1, 2, 3, and this is the 4. So 4-bit shift register we are taking here. So this is the circuit diagram for the shift register. Now we will see how to shift this information here in the circuit diagram. Now we will see here. So this is serial input. Serial input is nothing but we are giving the input here. Okay, so whatever the input we are taking, that will be applied here. And serial output is nothing but whatever the final result we are getting, so that we are collecting at this position. And here this clock pulse is applied to the each and every flip-flop, because flip-flop will be works depends on the clock signal only, right? So this is the basic circuit diagram. And here see, observe the circuit diagram of that means all the flip-flops, whatever the flip-flops we are connecting here. So in that the first flip-flop of output Q is connected to the input of next flip-flop. See, this is the output of first flip-flop and this is the input of second flip-flop, right? So that means output is directly connected to the input of next one, and the second one of output is connected to the third one of input, and third one of output is connected to the fourth one of input, right? So that means here each and every flip-flop will be connected in a cascaded connection. Okay, so that means chain of, here we are connecting the chain of flip-flops that will be connected in cascaded connection. Okay, so one of output is connected to the input of next one, and like that so on. Okay, so like this the circuit configuration is connected. So now we will see here how the information is transmitted, how the information is shifted. Now we will see here. So serial input, here we are taking the left side, no, but it is not in fixed. Okay, so this new information which I want to inject, okay, so the new information, whatever the information we want to inject into these flip-flops, I will be naming them as the serial input, right? So serial input determines what goes into the leftmost position during the shift, but it is not always the case. That means serial input is not fixed part of the left side case. Okay, so it could be say that the shifting may be started from right side part also. Okay, so serial input can be placed in left side or maybe right side also. That means shift register can shift the information in both direction. From left to right it can be shifted, or right to left also it can be shifted. Okay, that's why, so based on that information, based on that shifting, you can place it the serial input as maybe right side or maybe left side. Okay, so how to take it either left side or how to take it maybe right side means, for example, if you are taking shift right operation, okay, if you are taking shift right operation, okay, so where we are taking the serial input, that may be left side or right side of the shift register, means if you are doing shift right operation means compulsory shifting will be started from left to right. Okay, so then you have to give the serial input at left side position. Left side position you have to apply the serial input. Okay, so if you want to do the serial shift right operation, so serial input will come from the left hand side and the data will be shifted to the right side part. Or otherwise, if you want to do shift left operation, okay, so then what it will do, serial input we have to give at right side part. So remember these points. Okay, so for example, if I am doing the shift right operation, that's why I can do, if I want to do the shift right operation here, so that's why I can give the serial input at left side part. So right operation, no, so the data will be moved from here to here. So left to right it will be moved. Okay, so that's why we are giving the serial input. So for example, here already the data will be placed. So whichever the information you are having, as it is you can place it. So 0, 1, 1, 0, right? So now if you want to shift the information as serial input as 1, so this 1 will be shifted to here. Okay, so then the output will be 1 here. So what about the next case? Whatever the previous output we are having for this Q0, that is 0, no? So this previous output will be shifted to here, 0. And what about this Q1 of previous output? That means before output what? 1. So this 1 will be shifted here. So then what about the Q1 of previous output? So this 1 will be shifted to here. So and what about the previous output of last stage of this shift register, means this 0 will be discarded. So that means we can eliminate this value. So finally the new information we can get it as, here what is the new information we can get it? 1, and here what is the next input? 0, next output, and here this is the new information is 1 and this new information is 1. So actually we are giving the information as 0110, but it will be converted to the 1011. So like that we can shifting the information. Okay, so remember this one. So if you want to shift right, if you want to do the shift right operation, serial input will be given as here. Okay, if you want to do the shift left operation, you have to give the serial input is here and you can collect the serial output is here. So then what happened? Serial input we have to place here. So this one will be shifted to here, and here the whatever the previous information you are having, that will be shifted here, and here the previous information is shifted and the previous information will be shifted here. So finally this is the shift left operation. That means we can move from right to left. So the major point is left, no, at left only you have to collect the output. So shift right operation means at right side only you can collect the output part. Okay, so this is the basic shift register operation. Okay, so what is meant by shift register? Each and every register can shift the information in both the direction. So that is either right to left or left to right. So which register having a capable of shifting the information, that register we can call it as the shift register. Okay, so capable of shifting the information, that is called as the shift register. So in this shift register we have the two operations are there. So one is serial transfer and another one is serial adder. Okay, so now we'll see here first concept, that is serial transfer. So how to transfer the information in this shift register, now we'll see. So this is the basic circuit diagram for the serial transfer. So this serial transfer consists of the shift register A, shift register B. That means two registers we are using, A and B. And here we have one control pin that is represented by AND gate. So each and every AND gate will having the two inputs. So one input be represented as clock and another input will be represented as shift control. Okay, so and here one more thing, shift register as of input is connected to the output side, and here this output will be represented as input of shift register B. Okay, so this is the circuit diagram. So now we'll see what is meant by serial transfer. So serial transfer means whenever the information is transferred and manipulated one bit at a time. Okay, so if you are shifting from one register to another register, that is bit by bit, then we can call it as serial transfer. Okay, so what is meant by serial transfer? We can transmit the information here. So how to transmit that information? By bit, if you are transmitting information from one register to another register, that is called as the serial transfer. Okay, so here we assume that some continuity is already there in the shift register. So what happens means, here shift control pin and clock will be connected to the both the shift registers A and B. Why we are connecting here clock pin means, shift registers is nothing but that will be connected with the clock pulses, because if the clock is activated, then only the shift registers will be activated. Okay, so now in order to make that circuit function, which is given as the clock pulse for the both the shift register, and output of the shift register A is, that means this is the output of shift register A, is again given back to the input of shift register A. Okay, so whatever the output we are collecting from the shift register A, again that will be given back to the shift register A. Okay, so why we are giving again the output is given as to the input means, so with example I will explain clearly. Okay, don't take the confusion. So here remember one thing, shift register A output is again back to the given as input to the shift register A, as well as that output is given as input to the shift register B also. Okay, so this is the circuit diagram explanation. So now we will see how to transfer the information. So let us take one example. After that we will see the transformation. Okay, so see here, serial transfer example I can consider. So here I am taking the timing pulse, that is nothing but clock pulse we are giving in this block. Okay, so this is the shift register A and this is the shift register B. So now I will take one example information I can consider here for transferring that. Okay, so I can consider the information as some 1011 binary information I can consider. So that means shift register A consists of the 1 0 1 1. So this is the information shift register consists. So what about that shift register B information means, essentially it doesn't have any value, so directly we can consider as all zeros. Okay, so here for example we can consider the 4-bit shift register, that's why we can take it as 4-digit information. Okay, so shift register B information is all zeros and shift register A information is nothing but 1011. So the initial value before transferring the values will be this one. So first I am applying the first clock pulse. So at T1 clock pulse I am applying. Okay, so at time T1 the clock pulse will be connected to the shift register A and shift register B. So what happened means here at T1, so what I am giving the data here for shift register B and shift register A. So directly here shift register B information will be shift or it will be moved towards to the right side. Okay. So how to transfer to the right side means at T1 pulse. So whatever the LSB bit position, so you know already whatever the binary information you are taking, it will be having two places. So the first position of this bit we can call it as LSB and this position we can call it as the MSB, right? So here also the LSB of the shift register B will be discarded. So already I explained here whatever the first information we are having that will be discarded, right? So now this 0 will be shifted to the right side and this 0 will be shifted to the right side and this 0 will be shifted to the right side, right? So that means already the first 0 will be discarded, LSB of the register B will be discarded and the next LSB of the shift register will be moved to the first LSB of shift register A. So like that we can move the data. And coming to the what about the MSB bit of the shift register B means here what is the result of MSB of shift register B means shift register A of LSB bit we can shift it here. So that means it can be shifted to the right side position. So here this 0 will be shifted to this position and this one will be shifted to here. So what about the shift register of MSB bit position? So here observe the circuit diagram. So whatever the serial output we are collecting from the shift register A, so that will be connected to the serial shift register of the again input. So that means whatever the first input we are having the shift register A, so again that will be connected here. Okay, so this information will be placed here. So that's why shift register of first output whatever we are collecting, so that output again given back to the input part. Okay, so now coming to the T2 pulse. So after taking the second time clock pulse, so then what happened? Again the information is shifted to the right side. Same thing. So here 0 will be discarded. So this 0 will be shifted here and this 0 will be shifted here and this one will be placed here. And what about the fourth position of that means MSB bit position of shift register B? So shift register A of LSB bit is shifted here and here this 0 will be here and this one will be here and this one will be here. So what about this MSB bit position? Again the previous data of the input data we have to choose it. So previous data of 1101 in that input is what? 1. So this one will be placed here. Okay, so like that again the T3 pulse. So T3 pulse is nothing but again this 0 will be placed here and this one will be placed and this one will be here and this 0 will be moved to here and now this one will be here and this one will be here and this one will be here. What about here the previous of first bit is nothing but again will given as input to this one, right? So now last T4 pulse. Here we'll have the 4 digits, no? 4 clock pulses we have to apply. So same thing, this will be discarded. So again this one will be placed here and this one will be placed here and this 0 will be placed here and this one will be moved to here and 1 and this here 1 and here will 0. And what about here the previous information of input? So that is nothing but previous information of LSB bit we can shift it here. So 1011. So now finally after the 4 digits are shifted, so after 4 clock pulses reached, so then again we can get the same information of previous input whatever we are applying. So 1011 we are getting. See here. So whatever we are giving the input side at initially, so the same input we can get it as our output after transferring the 4 clock pulses. Okay, so this is the serial transfer information. So how to transfer the information from left. Shift right operation means like this we can shifting. Okay, so at the first place LSB of shift register B will be discarded and the remaining information will be shifted to the move towards to the right side position. So after reaching the 4 clock pulses, then we can get the as it is previous information. Okay, at initially whatever we are applying at input side, so the same information we can get it as at the output side also. Okay, so this is nothing but serial transfer functioning. Okay, so that's why here we are connecting serial output is again back to the serial input. So serial output is given back to the input is nothing but here. So here this one will be placed here and this 0 will be placed here and this one will be placed here. Okay, so again we have to back the output will be given as input to the shift register A. Okay, so this is the serial transfer functioning. So now we'll go with the next concept, that is serial adder. So this is the circuit diagram for this serial adder circuit. Okay, so here we'll have the shift register and shift register B. So two shift registers we are using, one is A and another one is B, and one more circuit we are using full adder. This is a combinational circuit, and one flip flop we are using that is related to the D flip flop, and one AND gate we are using here, that is one is used as a clock pin and another one we can use it as a shift right pin. Okay, this is the this is the clock pin and this is the shift control pin. Already here mentioned. So this line will be as clock and this will be as shift right pin. Okay, so SI is nothing but serial input, SO is nothing but serial output. Okay, so S means sum and carry. Okay, full adder will have the 3 inputs and 2 outputs. So the 3 inputs will be represented by XYZ and the 2 outputs will be represented by sum and carry. S will be sum and the sum C will be carry. Already we knows about full adder explanation. So go and check it out, the third unit combinational circuit of total unit. You can check it in that full adder concept will be there. Okay, so D flip flop we are using here. This is the clear pin for D flip flop for reset operation, and here we are connecting the AND gate as the clock pulse for the D flip flop. Okay, so now we'll see here. So here we are taking the shift register A and shift register B now. So what happens here means shift control should be 1. So shift control pin will be always chosen as 1 because these are the shift registers. Okay, and the clock signal should be given as to the flip flops because without clock signal the flip flop cannot work. Right, that's why we are connecting the clock will be connected to the D flip flop. Okay, so here the clock and shift will be ANDed together. That means these two are connected with AND gate. So that will be given as clock pulse to the flip flop. Okay, so now we'll given as here the information. So how to work it serial adder means if shift register A and shift register B having some information, so that will be given as input to the full adder circuit. So then what it will do, full adder means just it will do the addition process. Okay, so the full adder circuit is nothing but it will be having the 3 inputs and it will be produce the 2 outputs. By adding 3 inputs it will be produces the 2 results, one is sum and carry. Okay, so how to do that procedure means here shift register A will be consist of some information, like that shift register B is also having some information. In that, for example, it may be consist of 1011 and it may be consist of 1100. Okay, like this we are having the information. Now shift register A and shift register B, whatever the LSB bit positions we are having, so this 0 and 1 will be directly given to the X and Y values. Okay, so see here shift register A is connected to the X value and shift register B is connected to the Y value, and here D flip flop output is connected to the Z. But here at initially we didn't get any result from this. Okay, so you can assume at initially this value will be 0. Okay, so finally here 1 0 will be placed in the X place and Y place. Okay, so full adder operation is nothing but we'll have the two results now, sum and carry. So sum operation we can place it as, that is nothing but the result will be represented by full adder of sum, that is nothing but x XR y XR z. Okay, this is the output operation of the sum. And what about the carry function means? Carry is nothing but xy plus yz plus zx. This is the output function for the carry. So where we are getting these results means you can go and check it out, combinational circuits of full adder circuit. Okay, so already I explained these two results. Okay, so go and check it out ma. Here first the LSB bits are given to the x and y values. So what are that values we are giving? X is equals to what? 1, and what is the y value here? 0. And what about the z? Z at initial is 0 now. Okay, so now finding the sum result here. So all the three inputs are given to the full adder circuit. Now find it as output. So then sum is equals to 1 XR 0 XR 0. So x XR y XR z, no, I will place the values. Okay, so as we know XR result, 1 XR 0 is nothing but 1, 0 XR 1 XR 0 is nothing but 1. Again what about the next one? XR with 0. The remaining values I can apply it here. So 1 XR 0 again 1 only. So the first result 1 we are getting. What about the carry function means? So xy, x into y is nothing but 1 into 0, 0 plus yz, 0 into 0, 0 plus zx, 0 into 1, 0. So the first value will be carry 0. So finally the sum and carry will be placed as, first sum will be get it as 1 and the carry will be get it as 0. Okay, so after getting the result of by adding LSB bits of these two, so then we can get it as sum and carry. So that sum is again given back to the serial input of shift register A. Like this way the carry will be given as input to the D flip-flop. Okay, so whatever the result we are collecting from this full adder, again that is given back to the input path. So here the one is given back to here. So where we are placing this one? So this one will be placed here, MSB bit position. Whatever the previous bit you are having, so after that you can place it, that information. Here also the carry will be given as D flip-flop now. So this D flip-flop, what it will do, whatever the input we are giving, that will be as it is placed at the output side. So here we are getting the 0. Okay, so now this 0 will come to here, because this will be connected to the Z now. So that means the carry result will be given as next input of the Z. And what about the second position? Second LSB bit, what? Here we are having 1 and this is a 0, right? So now again place it. This is the 1 and this is the 0. So 1, 0 and the next bit is 0. Again you have to add these 3 bits. We'll get some result, sum and carry. So again after getting the result, after doing this operation, so again we'll get the result. That results will be given back to the again circuits. Okay, so that means LSB of B will be going to Y. Whatever the input we have given at previous case, that carry is generated as an input to the D flip-flop, that will be next given to the input for the Z. Okay, so now again it will be generated the sum and carry. So the process is repeated until we complete the addition of A and B bits. Okay, so if we consider 4-bit register, then we can take it as 4-bit information here. That means 4 clock pulses will be required in order to complete this addition of 4-bit values. For example, if you are taking 8-bit register here, so then 8-bit information you have to take it. So for that, for addition of 8-bit, you have to require 8 clock pulses. Okay, so the process will be going like this. After completing the A and B bits will be added. Okay, so thus the process will be continued up to we complete the addition of A and B bits. Okay, so this is the process we are having in serial adder. So totally in shift register we have the serial transfer, basic shift register information, and another one is serial adder concept. Okay.